Just in brief, I want, not details I'm asking. What does merge instruction do basically? How many operands are there for merge instruction? Explicit operands. Yes, students, be interactive. How will you give a merge instruction? Merge instruction and how many operands? Okay, merge is unsigned integer multiply. Okay. What is imul? Imul is signed integer multiply. Okay. And how many operands do you specify in the instruction when we give for merge? When you give the instruction for execution, how many operands do you specify in the instruction for merge instruction? We discussed that in the last lecture. Yes, we give one operand, isn't it? If it's a 8-bit multiplier, how you specify it? Mul BL, isn't it? Just you don't forget the previous sessions, okay? I've not shared the PPT, I shared it today or tomorrow. You can revise it later on, okay? But remember the points, whatever I have been taught, okay? So mul A BL is a example of multiplication instruction with one operand, 8-bit multiplier, okay? Then what is due instruction? Yes, what is due instruction? It is due Rutuja, not mul. Due and I due. Yes, that's correct. So due is unsigned integer division and I due is signed integer division. Okay? Okay. Then we saw some logical instructions. Which were the logical instructions that we saw? and not or XOR. Okay, that's correct. So I think XOR instruction was remaining. So we start with the XOR instruction. Okay, and or and not, I think you have understood. Okay, it has two operand, and destination operand comma source operand. And when you give the instruction and destination operand comma source operand, destination operand equal to destination operand and source operand, the result is stored into destination operand. Same for or, and same for XOR also. So for XOR, basically you will have XOR destination operand comma source operand, and destination operand equal to destination operand XOR source operand. The result will be stored in the destination operand. Okay. Yes, is the screen visible to you? Okay. So that was the remaining of the Boolean operation instruction, XOR instruction. Okay. So speaking about XOR instruction, you will have, let's say I have XOR. So I'll give it like this. The instruction XOR, and let's say two registers, destination operand comma source operand. So when I say XOR AL comma BL, what will happen is that result of this will be AL will store the value of whatever is the value in AL XOR BL. So AL XOR BL will be stored into register AL, because AL is the first operand. So first operand will be the destination operand, second operand will be the source operand. Okay. Getting XOR instruction. So the XOR instruction can have byte sized operand, word sized operand, and double word sized operand. So this is an example of byte sized operand. Okay, can you give me an example of word sized operand for XOR instruction? Yes, what will be the example for XOR instruction with a word sized operand? Yes, students. Can you give a XOR instruction with a word size operand? Word size means 16 bit. So the operand should be a 16 bit. It can be a register. It can, the source operand can also be a constant immediate value also. So for a register, can you give me word size operand for XOR instruction? Yes, Kiran. And Nikita has given XOR AX comma DX. Is it correct? AX will be a 16 bit operand or word sized operand. Okay. AX and BX. Okay, so I think you're clear with XOR instruction. Okay, yes, clear with XOR instruction. Another thing, the destination operand can be a register or a memory variable, memory operand. The source operand can be a register or can be a uh, immediate value. Okay, like for example, if I give it like this, if I say XOR L comma 05, so this is also acceptable. You can have the source operand as a immediate value. You cannot have it as a destination operand because you cannot store into constant. Okay, but constant can be given as a source operand. Okay, okay. The next are the bit test and modify instructions and bit scan instructions in logical instructions. Okay, the bit test and modify instructions and bit scan instructions. Okay, so bit test and modify instructions, they basically operate on single bit within the operand. A register, or the operand can be a register or a memory location, that is a variable. Bit location is specified as an offset from lower order end of the operand. Okay. Example of bit test instruction is BT instruction. So BT is a bit test instruction. Okay. So what happens in case of BT instruction is that whatever is the second operand value at that index, basically the bit is checked. Whatever is the bit value, that value will be stored in the carry flag. Okay, and effect on the selected bit will be none. Okay, like for example, if I use BT, suppose I say EAX register, comma 05H. If this is the instruction I give, BT EAX, comma 05H. So what is the second operand given? 05H. So what will happen is that in the EAX register, the bit 5 will be checked. So in the EAX register, so EAX register will be a 32-bit register. So you have bit 0 to bit 31. So in that, the bit 5 of the EAX register will be checked. If that bit value is 0, then what will happen is that carry flag will store the bit value. So what will happen? Carry flag, since the bit value is 0, carry flag will be stored with the bit value 0. If this bit value would have been 1, okay, it would have been 1, then in that case carry flag would have stored 1 value. So whatever is the second operand, that index bit is checked for 0 or 1, and accordingly the carry flag is set to 0 or 1 depending on the bit value. That is the use of BT instruction, bit test instruction. Getting the BT instruction, so the bit is not modified, only the bit value is stored into the carry flag. That is the BT instruction. Yes, clear with the BT instruction? So I showed you an example also, like BT EX, 05H. So what is the bit value, bit number given? 05. So in the first, so what are you can use EAX, EBX, ECX, EDX, so on. Any register can be used, or even a variable can be used here as a this first operand, destination operand. And whatever is the bit value will be copied into the carry flag. Clear with this? Yes, students, clear with this? Yes, have you understood what is the BT instruction, students? Or are you still not understood? I'll repeat it then. Are you clear? BT, first operand, comma, second operand. Second operand is the index of the bit to be checked in the first operand. So whatever is the second operand given, that bit value is checked in the first operand. And if that bit value is 0, 0 is copied into the carry flag. If that bit value is 1, 1 is copied into the carry flag. Getting this? Yes, students, be fast now because we are lagging behind in the syllabus. I can't go very slow now.
Yes, sir.
Okay, please be attentive because we have gone very slow initially because of the new subject. We are still in the unit 1. Okay, so I cannot allocate too much time for every instruction. We have already allocated a lot of time for every instruction. I need to go fast now because we cannot. The other part of the syllabus is also important. I know instructions are important for your programming also, so I went a bit slow, but you cannot go very slow also. Okay, lot of instructions are there because in the subject. Okay, clear with this BT instruction?
Yes, sir.
Okay. See, for example, if I have like this, if I say, let's say, move L comma 0 to H, and I say BT L comma 01H. So what will be, so this kind of questions can come in your online exam. What will be the value of carry flag? I have move L comma 0 to H, BT L comma 01H. So what will be the value of the carry flag? Can anyone tell me what will be carry flag? This kind of questions come on instruction set. See, I have move AL comma 0 to H. AL is moved with 0 to H. BT AL comma 01H. So what will be the value of the carry flag? Yes. Check it basically. Write down the AL value in terms of bits and check the bit index of that bit and check whether it is 0 or 1. Accordingly set the carry flag. So I have shown you the instructions. Write down AL as 02. Okay, in terms of bits, it's a hex value. So 0 will be 0000, 2 will be 0010. Check the one numbered bit in that. Bit starts from 0 to 7 and check the carry flag. So what will be the carry flag? Yes. What will be the carry flag? See, bit starts from 0 basically. First bit is 0th bit from right, then 1 bit, 2 bit, 3 bit, 4 bit, and so on till 7 bit. So Apurva is saying carry flag is 1. That's correct. Isn't it, Kiran? It will be 1. How come? See, 0, 2 will be written as 0, 0, 0, 0 or 0, and 2 will be written as 0, 0, 1, 0. And the index will start here 0, 1, 2, 3, and so on. So we have to check the bit 1. So the bit 1 is having value 1. So what will happen is carry flag will have value 1. Getting this? Everyone? Yes, clear with this? Yes, students, clear with this? Yes.
Yes, sir.
Okay. The next is bit test and set. So it is similar to bit test. In this also the bit is checked and the carry flag gets updated. But once the carry flag is updated, the bit that we are considering will become 1 basically. So bit that is being checked will be set in BTS instruction. So BTS, whatever it is, the operand, first operand, comma the index. Okay, like for example, if this would have been like this example, here it would have become BTS. So carry flag would have been 1 and the bit also L would have remained as 0 to H because that bit would have become 1. It was already 1, so it would have remained 1. So what would have happened is that L would remain 0 to H because that bit, it is already 1, so it would have remained as 1. If it would have been 0, it would have become 1 after the BTS. So in case that this bit would have been 0, then it would have been set to 1 basically after BTS. Getting this BTS instruction? Same as BT instruction, only after execution the carry flag will also be updated and that bit would also become 1 if it was 0. If it was 1 already, it would remain 1. Okay, getting this? So same as BT, only it is set after execution. If it is 1, it remains 1, that bit, and if it was 0, it becomes. But before that, the carry flag gets updated as per the current status of the bit, and then it is set. After checking, it is set later. Getting this? Okay. Okay. Then after bit test and set, you have bit test and reset. So what does bit test and reset do? Is same as bit test. The bit value is copied into the carry flag. But after it is copied into carry flag, the bit is made as 0. So in bit TR instruction, the bit is made as 0 after the carry flag gets updated. So in set basically it is made 1, whereas in reset it is made 0. Whatever is the bit value, 0 or 1, it is made 0. If it was 1, it is made 0. If it was 0, it is kept as 0. Getting this concept, BTR, same as BT, carry flag updated as per the bit value, but after the carry flag is updated, the bit is made as 0 in BTR, whereas in BTS it is made as 1. Okay. Getting the BTR instruction. Okay. Like for example, suppose I have move L comma, it's again I have 0 to H. Then I say BTR L comma 0 1 H. So the question will be like this. They will give these instructions. So what is the value of carry flag, and after BTR what is the value of AL register? So this is the question. Move AL comma 0 to H, BTR AL comma 0 1 H. So what is the value of carry flag after that, and what is the value of AL register after that? Can anyone tell me? Carry flag will be simple. What about AL? So these are the two instructions given. Move AL comma 0 to H, BTR AL comma 0 1 H. So what is the value of carry flag? What is the value of AL register? What will be the carry flag first of all? How come it will be Rutuja 0? Because you have to update the carry flag before the reset of the bit. First do the carry flag updation and then reset the bit. Isn't it? So carry flag will be 1. That's correct. What will be the value of AL register? 0. That's correct. Okay. So that will be how ABTR will be executed. Okay. Okay. Then the last in the bit test instruction is BTC instruction. Bit test and complement. Complement means what? Whatever is the bit value, if the bit value is 0, it is made as 1 after the carry flag gets updated. First the carry flag is updated with the old BT bit value, and the new bit value is complement of the bit. So if the bit value is 0, it is made 1, and if it is 1 bit value, it is made as 0. That is the BTC instruction. Getting the BTC instruction, so whatever is the bit value, first it will be stored into the carry flag, and then the bit value will be complemented. If it is 0, it will be made 1. If it is 1, it is made 0 and put into the right register. Okay? Getting this? Yes, getting the concept of BTC instruction. Yes, students. So for the same thing, instead of BTR, If I use BTC, what will be the result of this? I have the same thing, move AX comma 0 to H, BTC AL comma 0 1 H. What will be the carry flag and what will be the AL value? Yes, carry flag will be 1, that's correct, and AL will also be 0, same thing. So it will work because that's the case, because that bit is having 1 value. So after BTC also it is becoming 0. If it would have been 0, it would have been made 1. So BTR and BTC are different in that case, but since it was 1 already, so BTR and BTC has given the same result. Okay? Clear with this? So for that example, for BTC example, basically what is in AL? AL is having 0 2. So 0 0 0 0 and 2 is 0 0 1 0. This is your 0 and this is your 2. Now bit 1 is this bit. So with this 1, so what will happen is that carry flag will be put value 1 in it, and since this is now BTC, so 1 will be made as 0. So this will change to 0 0. So AL will have value 0 0 H. Okay, so this will be the result. Carry flag will be 1 and AL will have 0 0 H. Okay, clear with this? Okay. Okay. The next are rotate and shift instructions. Okay. So you have shift instructions like SAL. SAL, shift arithmetic left. Okay. Then you have SHL, shift logical left. Then you have SHR, shift logical right, and SAR, shift arithmetic right. So these are the basically shift instructions in the shift and rotate instructions. Okay. So what do shift instruction do is that if it is shift arithmetic left, so whatever is the value in the register basically will be shift left by the value given in the second operand. So like if I say, let's say S A L comma 0 1 H, then what will happen is that since our second operand is 1, whatever is the value of the AL register, each bit will be shifted left by 1, and whatever is the result will be stored into the destination operand 1. Destination operand 1, that is in AL. So like for example, if I have given these two instruction, if I have, let's say, move AL comma 0 1 H. Okay. So what will AL contain? AL will contain 0 0 0 0 and 0 0 0 1. Now since I am shifting arithmetic left by 1, what will happen is that this thing will be shifted left by 1. So what will happen is that this 1 will go here, zeros will go here, and so on. So what will be the result is that, and the MSB will be discarded. So the result will be 0 0 0 0 and 0 0 1 0. AL will contain now 2 basically after SAL, AL comma 0 1 H, because 1 has shifted by 1 bit to left because the second operand is 1. If this would have been 2, this would have gone here and this would have become 0. Okay. So if it would have been 2 shift by 2, 2 bits it would have been shifted. Depending on what is given as the second operand, that many times it is shifted basically. Getting this SAL instruction, same with SHL instruction. Shift left, shift logical left. SHL is what? Shift logical left. Okay, SHL is shift, both are similar, SAL and SHL. Shift arithmetic left and shift logical left. Getting the concept of SAL and SHL instruction? Yes, understanding SAL and SHL instructions, shift arithmetic left and shift logical left. It shifts by left by the number of bits given in the second operand, or you can give it basically uh, in the count register CX. Either give it in count register or give it as a second operand in the instruction. So like for example, if I have, let's say, I give SHL AL comma 01H, and I say, let's say, move AL comma, before that I move 02H into AL. So the question will be like this, these two instructions will be given, and what will be the value of AL? So move AL comma 02H and SHL AL comma 01H. So what will be the value in the AL register? Yes, what will be the value in the AL register after this? Move AL comma 02H and SHL. SHL is similar to SAL, I told you. Okay. So what will be in the AL register? Write down AL as 02, as 00000010 and shift it by 1 bit to the left, each bit in the AL register. Yes, what will be the result in AL register? See, I am taking very simple examples. I am taking only 8-bit operands. This can work for a 16-bit also and 32-bit operands also. So I am not saying that that will come, but they can give you a 16-bit operand also in exams. That means they use AX, BX, CX and so on, DX. Yes, what will be the result of the above example that I have given? What will be in AL? So Nikita is saying 04, that's correct. AL will contain 04H. Why is everyone taking so much time? Simple. Write down 02H in binary and shift it by 1 to the left. Not difficult. Simple example I took. So what will be the case? 02H will be written as 0, 0, 0, 0 and 2 will be written as 0, 0, 1, 0. Now since AL and SHL with second operand as 1 is given, it will be shifted left each bit by 1 and the MSB will be discarded. So you will have 0, 0, 0, 0, 0, 1, 0, 0 and from right zeros will be added. Okay, so you get 04H. as the output in AL. So AL will have 04H. Getting this? Yes, clear with this? Similarly, you have shift logical right and shift arithmetic right. It shifts to the right now. Whatever we had seen going to the left in SHR and SAR, it goes to the right. Only difference in SAR is that, as compared to SHR, is that in SAR, whatever is the carry flag value, whether it's 1 or 0, that will be added from the left. Remember that. It is same as your left shift and right shift. Only in SAR, in SHR it is 0 only, but in SAR the carry flag if it is 1, ones will be added from the left. Remember that difference. Okay, so that is the only difference in SAR, shift arithmetic right. Not the carry flag, sorry, just hold on. Sign of the operand, not the carry flag. Don't by mistake I said carry flag. Whatever is the sign of the MSB bit, sign bit, that will be added from the left, not the carry flag. So if the number is negative, ones will be added from the left, and if it is positive number, zeros will be added. I said carry flag by mistake, I said that. Remember that it is the MSB bit that gets added from the left for SAR. We'll discuss that in the next lecture again. Okay, are you getting an idea at least what is SHR and SAR? Similar to left shift, it is right shift. Okay, yes, getting it. We'll discuss that in the next lecture again in brief basically. Okay, see, the syllabus is vast, so as much we take is less basically. Okay, we have to cope up with the syllabus. Now since the instructions are important, so I am going in detail of that. Okay, but once you understand the basics, we can go fast then. Okay, so once you get the basics, maybe the next parts of the units will be can go a little bit faster in the next part of the units. Okay, okay, give me a few minutes, I'll just take your attendance.